With increasing thinner, lighter, and smaller 3C products being made available in the market, their parts and components are becoming highly accurate and miniaturized, e.g., carbon steel screws in a mobile phone or small bearings and gears in a small motor of a fan are common micro parts. Therefore, the heat treatment process of a micro part plays a crucial role in the entire production. Specifically for micro parts with a diameter less than 2 millimeters, MIRDC has developed the world's first continuous micro part heat treatment system equipment, which consists of the automatic feeding system, the Carburizing quenching furnace, an oil tank, the collecting device, the cleaning tank, a tempering furnace, and the furnace gas generation and monitoring integration system. Depending on product or functional needs, it can quickly change the modular combination, allowing the equipment to have more flexibility and mobility in operation. In comparison to the traditional heat treatment equipment, it possesses 4 innovative design functions that can solve the dilemma of inconsistency quality and poor collection of microparts caused during carburization and quenching, facilitating microparts to be equipped with excellent mechanical property and yield rate, high collecting rate and highly efficient production schedule, thus lowering manufacturing cost and increasing safety and stability of the final products. 1. Automatic feeding system. The system combines transport and vibration functions, replaces fine steel mesh wrapping, allows all parts to be evenly distributed on the plate without being stacked or squeezed to give sufficient heating space and prevent microparts from deformation. 2. Carburizing quenching furnace. The furnace uses a small heating range design and shortens heating duration. With the monitoring system in series, it can automatically monitor and adjust the real-time temperature, carbon potential, furnace gas flow within furnace, and maintain a stable in-furnace environment condition, enabling microparts to meet the required consistency of carburization layer and depth, increasing the mechanical properties of the parts. 3. Oil tank. The exterior of the funnel mechanism is surrounded with spiral cooling tubes that is completely filled with quenching oil. Without being wrapped with a fine steel mesh, microparts can directly, freely fall into any part of the funnel mechanism to be quickly and evenly cooled. Thus, the quality yield rate is increased as well. 4. Collecting system. It consists of the connecting tube and the collecting filter tank. By using the vortex attraction force created by the cooling tube, connected to the bottom of the funnel mechanism, microparts can be caught and quickly sink to the connecting tube, where microparts are transported to the collecting filter tank and will not be attached to the filter tank, achieving a high collecting rate and solving the problem with raw materials wasting or even materials mixing in a traditional heat treatment process. Afterwards, MIRDC introduced intelligent and digital service functions. The traditional heat treatment experiences were transformed into the data bank. Further, judged by AI integration, the heat treatment process parameters can be accurately provided for a particular material, enabling microparts to be able to precisely fall within the required specifications, regardless of the hardness, carburized depth, sizes, etc., which lowers dependence on human experiences and trial and errors, thus increasing the production efficiency. In the meantime, an industry-exclusive IoT program was established. Through the cloud service, the SaaS module, dispatch, commission, upgrading, shutdown exclusive for intelligent production of the heat treatment industry are provided, achieving the goal for intelligent production, which have now been used in optoelectronic semiconductors, 3C products, medical machinery, robots, electric vehicle, motorcycles, aerospace, etc. The intelligent continuous heat treatment procedure can bring about the high-value development of the relevant industries.
Electricity is an indispensable foundation of modern life, as well as a driving force for the economic development of traditional industries and high-tech emerging industries. By promoting and building onshore wind, offshore wind, and solar panel power generation, domestic and foreign green power industry shall get more influential support to pursue more stable sources of power. In view of the variability of the wind field, sudden gusts and disturbances such as vortexes and turbulences generated by the wind turbine, traditional wind turbine inspection requires stopping the operation first and then performing inspection and maintenance by sending humans up the turbine. However, interrupting the operation can be expensive. Take a 500 gigawatt wind turbine, for instance. It generates approximately 4,800 million kilowatts of electricity, which converts to 24,000 Taiwan dollars per hour. Although in recent years, drones have been used to replace human inspections, factors such as the inability to generate electricity and losses caused by a single shutdown and the power required for restarting are making companies re-evaluate wind turbine inspection methods. RTURB, Rotating Turbine, UAV Inspection System by MIRDC. Not limited to the existing method of shutdown inspection, RTURB UAV carries out effective, highly anti-interference inspection with high-altitude stability even in the face of running wind turbines. Strong stability and high security. Contrary to the current inspection systems, which require complicated path planning, the algorithm adopted by IVC D15, 8 UAV, Intelligent Vehicle Center, Drone 15, 8th generations, unmanned aerial vehicle, can control rapid convergence, and the instantaneous error of altitude and position during flight can quickly converge to zero, hence withstanding the instantaneous wind speed and wind direction changes of altitude and the generated vortexes. The RTURB UAV is featured with heavy payload, a load of 40 kg, extended range and high altitude, even under harsh conditions, level 7 gusts or above, and can stay in the air for up to 2 hours. Even without stopping the turbine, the defect inspection can be carried out safely. Significantly shortening inspection time. IVC D15 8 UAV starts from the axis of the turbine. As the turbine rotates, a dynamic turbine sampling program is adopted. The rotating blades actively and sequentially enter the range of image sensor and stop radically outward to capture the images of fan blade defects. The number of stop points varies according to the forms and sizes of the turbine. The inspection time can be shortened from 25 minutes to less than 5 minutes of a single wind turbine. Scale inspection with swarming formation. Under the inspection architecture of the RTURB UAV inspection system, multiple UAVs are used to perform large-scale inspections of multiple wind turbines simultaneously. Before a task, the system first obtains the coordinates of each wind turbine and ground station, and the inspection and deployment control system guides the UAVs to form a communication interconnection formation and set out the coordinates of each UAV while performing tasks to ensure that they can communicate with the ground station during the task. After the inspection is completed, the system will be notified immediately and the formation will be recalculated to continue the inspection task of the next target wind turbine. The system effectively expands to large-scale inspections, enhancing the efficiency and scale of inspection. The high-efficiency inspection operation mode of RTURB UAV inspection system brings innovation to the current inspection methods and improves energy efficiency, using power wisely, reducing unnecessary power waste, and creating a more convenient living environment.